All right, the last video we did, we created a Teach Pennant program, and then we uh, added motion instructions for that program to move around this box, the surface of this box, and return back to the starting point. So, and then we walked through, we tested that program using the step method, testing one line at a time. Then we tested it with the step off and just walked through it, but at teach speeds, and made sure that the program was okay. And then we ran the program in full auto. So when we did that, we did notice that as the robot moved around this square, it didn't actually move in straight lines, even though point 1 to point 2, here's point 2 over here. So even though point 2 or point 3, point 2 is in a straight line from point 1, point 3 is in a straight line from point 2, and point 3 is in a straight line from point 4 and back to 1, the robot's not moving in a straight line. That is because our motion instructions over here, we're using joint movements. The joint motion type is a very smooth movement for the robot. It's very easy for the controller to determine how to make it move. It has it has the least amount of strain for that particular move from one point to another. All right, so it's a nice smooth movement for the robot, just like it would be for your actual human arm. But a lot of times we really need the robot to move in a straight line. So to move in a straight line, we can come over here and we can change the type. So notice when I come to the J for joint, I get that choice under F4. So I press F4 and we have three choices. We have the joint, or a linear motion, or a circular motion. So right now I'm just going to choose a linear motion. So I have my linear motion. And so I'm going to select that. I guess I didn't select it. Oops. All right, so when we look at our motion instruction, okay, we have the motion type. So the first option here is the motion type, and our choices are joint, linear, and circular. All right, and then the next one is our point. Okay, so the next one is our position. This is where the robot's going to move to. Now remember, this motion instruction doesn't say where the robot is coming from. It simply says where the robot's going to. All right, but it says we're going to move 2.1 in a nice smooth joint sort of motion because the type of movement is J, and I'm going to move at 100% speed. So I'm going to move as fast as I can. All right. And then the fine says I'm going to stop there. So before I actually make changes here, let's just run this one more time. The fine is what we call the termination. And the termination means that it will stop at that point. Beyond that, if we come over one more past the fine, we see that there's still a choice, and the choices are options. And so right now it's blank, so that's a no option. I can change options. I can do are a lot of different options. I can set acceleration modifications. I can set offsets and things. We'll talk about those later in the semester. All right, but so the motion instruction here has 5 parts: the type of motion, where it's going to go to, the speed, and the termination, and then an option, or you can actually have multiple options on the same line. All right, so again, motion type J means that it's going to be a nice smooth motion. The P means this is a point inside of my program that has been saved, and this is the point I'm going to move to. Now you have two choices under points. One is a point, and the other is a position register, PR. Okay, position registers, you can, when you move to a position registers are defined values. We can see those under the data. So if I go to data, select type, go to position register, these are the position registers. And these position registers are available to all programs. So position register number 1 is a position register that I can use for every single program every program can use that position register. However, if they're using different frames, if you got two different programs using two different frames, then that position register might be a different place in space than because the frame is a different frame. All right. Now, but point 1, like here you see I've got point 1, 2, 3, and 4. These point 1 in this program is a completely different point than point 1 in some other program I may have, or every other program I have. So every program that contains a point 1 does not mean they're the same point in space. Most likely they're not. Most likely they're different points in space. There's no relationship between P1 in this program and P1 in any other program other than pure coincidence. All right, so, but I'm going to run this. I want to talk about the termination here. Notice that the termination right now is set to find. Find means it's going to move to that point and stay at that point. Okay, so I'm just going to run this in auto one more time, and notice that it makes a small hesitation at each point. As it gets to point 2, there's just a slight hesitation. It's running in full auto, so it's not much of a hesitation, but there's just a slight hesitation because it's actually going to stop at that point. So it's going to stop at each one of those points. All right. So now I'm going to change my types from joints to linear. So again, notice the joint motions. When you do the joint motions, they're arcing sort of motions. They're not nice and smooth. Watch it one more time before we make the change. So we see it's an arc. It's the lines drawn are kind of jagged, but the actual motion is a smooth arcing motion. And so I'm going to change these. Now, notice to make changes to your program, you must turn the Teach Pennant on. You're not allowed to come to edit. You can go to edit and see the lines of code while the program is running in auto, but you cannot make actual changes to it if the Teach Pennant is turned off and the robot is in auto mode. But turn the Teach Pennant on, I can come over here to choice, and I'm going to change the choice to linear. Okay, before I do that, notice that the speed, these are all joint motions and they're all 100% speed. If we go to choice, I have 3 choices in speed. Either percent, which could be, anywhere from effectively, I guess, 0%. I never tried that, but at least 1% to 100%. And then, or seconds or milliseconds. So this is kind of cool because if I come over here to the speed, I could actually come over here to speed, change the speed choice and make it seconds. And I can say, I want you to take 5 seconds or 10, it defaulted to 10 seconds there. But let's just say I want to take 2 seconds, 2.5 seconds for you to go from point 1 to point 2. And so if I run that then, if I go ahead and run it now, let's go back to auto mode one more time just for the fun of it. All right, notice that it's going to move really slow compared to, all right, so this first move from point 1 to point 2, right here, takes a little while to get going, but I guess it was kind of hard. I didn't really notice it in the software, but on the real robot, you would notice a definite change here. let's just make it 0.1 second. So let's just say it's going to take 0.1 second. Again, you got to turn your teach pendant on to make program changes to the program. Pressing the auto cycle start button up here will do that. So I didn't really see, in the software simulation, I don't really see a change in that speed. But on the real robot, you would definitely notice a change in that speed. All right, turn the teach pendant on. Now I'm going, okay, so the speed choices for a joint are percent, second, or milliseconds. So seconds say from where you're at to where you're going. Oh, that's why it wasn't changing. I'm sorry, I should have changed, because 0.1, it was actually already at 0.1. So that's why that speed didn't change. Let's try changing speed from 0.1 to 0.2. So I'm going to change it to seconds. And I'm going to say, let's take, actually, I guess I was going the wrong way anyhow. Let's take 20 seconds. Let's take 20 seconds to go from 0.1 to 0.2. All right, and so I'll run that in auto mode. Yeah, I was going the wrong way there. So you see how slow it is taking, how much time it's taking to get to 0.2? Because I told it take 20 seconds to go from where you're at, which was 0.1, to 0.2. I was changing the line 3, which is 0.1, but it was actually already at 0.1. So you see how long it took for moving from 0.1 to 0.2? Because I'm telling it take 20 seconds. I didn't actually time that with the simulation software, but I'm saying take 20 seconds to go from 0.1 to 0.2. So I think that's pretty impressive that the software has got to calculate how fast to move all the joints so that it can take exactly 20 seconds to move between those 2 points. That's some pretty impressive math. All right, so from there, I'm going to come down here now. I'm going to turn teach pendant on, and I'm going to change these types. I'm going to go to choice, and I'm going to choose linear. Okay, so now notice when you go to linear, you don't have a percent speed, but you can define what the speed is going to be in millimeters per second, or centimeters per minute, or even inches per minute if you prefer. You can also do degrees per second. Okay, degrees per second for a linear type move don't make a whole lot of sense unless all you're doing is rotating like axis 6. Then degrees per second would definitely make a lot of sense. And when we get to the circular motion, degrees per second obviously applies to how many degrees per second you're going to be traversing through the circular motion. All right, so, but I changed it to linear, and now, again, we can go to choice, and I can say, let's move at, say, 5, F4 millimeters per second, and then we can type in a number, 5 millimeters per second, or whatever, depending on which robot you have. Right now, I have a 200 IC robot. These actually have a speed rating of 4,000 millimeters per second. So I could put in a speed here. Actually, you'll see that if I come down here to this one that's set up to 100%, and I change the type to linear, you can see that it automatically set the speed to 4,000 millimeters per second, because that's how fast this robot can go in full auto. All right, so we, again, hit F4, go to choice, make that linear. We can say take 20 seconds to go from 0.1 to 0.2. Change this one. I'm going to change this one to a joint, or to a linear. And I'm going to change this one to a linear. All right, now remember, the termination is still fine. So when I run this, I'm just going to run it in auto mode. But notice now it's moving in a perfectly straight line. This motion is going to take 20 seconds to go from 0.1 to 0.2. So it takes a little while, 20 seconds. We'll have to time that on the video and see if it's actually that long. But now notice how it traverses a perfectly straight line. All of these were changed to linear, so they're moving in a linear motion. All right, and so with a linear motion, you can't say move at 100% speed, but you can say move at full speed, which for this particular robot is 4,000 millimeters per second. Notice other robots have different maximum speeds, so 4,000 may not be valid for some robots. The 200 ID robots are only rated for 2,000 millimeters per second, so you can't put in 4,000 or even 3,000. It won't allow you to put that in. All right, but also notice when you run this, I'm going to change this. 20 seconds is a really long time, right, when you're waiting this. So I'm just going to change this to say 2 seconds. So I'll come over here, press the number 2, press enter. Oh, my teach pendant is disabled. Look at the error message. You see up there at the top of the teach pendant display, teach pendant is disabled. You can't make changes when your teach pendant is disabled. That's why it wasn't letting me enter in a 2. All right, so always look at your teach pendant, look at the error messages. All right, so I've set that to 2 seconds. I'm going to run this again, and I want to point out that when this thing runs, it physically stops. It physically stops at 0.2, 0.3, 0.4, all right? Because the fine termination says get to that point and stop. Even if it's just a hesitation, but you're physically at that point and stopping. So let's see what happens when we change our termination to continuous. So I'm going to come in here. Now notice line 3 really isn't doing much right now because I'm ending at 0.1. So line 3 isn't actually doing anything. So just to kind of show you that, what I'm going to do is, before I actually do anything else, I'm going to just jog my robot. Whoa. I forget, this thing always puts you at 100%. So this robot just went out of town, right? So, trying to bring it back in, but more slowly. Right, so here's my robot. And I just want to make clear, right, this robot is not currently at 0.1 anymore. All right, so the robot is way up here somewhere. It's not at 0.1. So now if I run this program, notice that the first motion on line 3 here is going to take it from where it's currently at over to 0.1, and it's moving at a speed of 5 millimeters per second. But also note that if something is in its way, it's going to run through it. There's nothing in this instruction that says, you know, hey, look out, there's an obstacle in my way. So when you start programs, you need to make sure that the robot is in a clear space and it's not going to wipe something out trying to get to its first point. All right, so in general, we want to create a home point up above our working points that is in a nice clear area. And then we can start our robot kind of up near that home position. So let me kind of show you that. Now I'm going to insert a line. So I'm going to come here to line 3. I'm going to go to next, edit command, insert. Notice it's the first option. I'm going to press enter. It wants to see how many teach pendant on. Edit command, insert. It wants to know how many lines. If you just want one line, you can just press enter twice real quick, boom, boom, and you get one blank line. Now I'm going to arrow back next, and I'm going to create a point, but this point is going to be up here somewhere up in the middle of space here, clear from any obstacles. So really, and we can come over here and I can label this point. So notice here, I'm going to press enter here, and I'm going to call this home. Now, we can actually use a keyboard on on our teach pendants, you can plug in a wireless keyboard, USB dongle sort of keyboard into the teach pendant and use an actual keyboard if you have that, or if you have the newer robot, it actually has a touch screen. You can select keyboard and punch in the number. But on this older robot, I'm just gonna call this home. So this is gonna be H-O, and now at right arrow M. I can't see that changing. Oh, I'm hitting the wrong key, sorry. M, E, B, C, D, E. Okay. Press enter and it'll say that. So we can label these points. Like this point here, P1, I can label that point, come over to it, press enter, and I can then come over here and I can label that, and I'm going to say that's the right corner. You know, I can call that the right corner or something. I'm not going to type it all in here. You don't want to watch that, but you know, I can just call this right rear. I'll just abbreviate for right now. I mean, it's better if you spell it out, but you guys don't want to watch me go through all these letters here. I'll just call it right rear corner, the one closest to the robot. Okay, and we can label these points. All right, so now notice I'm modifying the program. Now I want to also return to point 5. So I'm going to press shift point again, and it gives it a brand new point, but I'm going to come over here and I'm just going to punch in the 5, and notice it labels it as home for me again. So this is my home point up here away from the robot. Okay. And so now this program is going to run just about like before, only it's going to actually move to the home position. So again, if for some reason your robot, you know, like we don't necessarily have to worry about where the, whoa, see, I just crashed my robot there. Okay. So we need to, I hate it when it makes that speed so fast. Okay. So what I'm going to do is I'm just going to kind of move this off a little bit. So I'm not at my home position, but I'm up above in a clear area. And I know that my home position is over there and the robot can get to the home position without running into anything. So I can always just move my robot up here into the safe area, then run the program. The program is going to go to the home position first. Then you see that line there, that's just it moving to the first position. Then it goes around the cone, and then it was supposed to return home. Why did it not return home? Joint motion home. Apparently point 5 and 1 were the same point. I didn't want that. So let's see, where's my teach tool? Okay. All right, so I wanted point 5 up here, should be this home position, somewhere up here in a safe area. All right, so if we look at our robot from a distance, we just want it to be up here in a safe area. And so now, and I ended up saving it as 0.1. So 0.1 and 0.5 were currently are the exact same point in space. We can see that if we come over here to the point P and press position, we can see that, you know, X is 299, Y is minus 199, Z is minus 129. That's for 0.5. And then if I go back and come to 0.1, we can see that it's 299 minus 99 minus 129. So currently 0.1 and 0.5, although they're different points in the program, they're the exact same place in space. But I'm going to come over here now and I'm going to do a touch up, and I'm going to make this point up here away from my box in a safe area my home position. So I'm move it up into this home position and do a touch up. All right, so I've done a touch up here. So if we look at this point, then it asks, because I've got 2.5s in the program, it says, do I want to renumber this 0.6? And the answer is no, because I want to keep both this 0.5 and this 0.5 both as my home point. So I said no there. Sometimes you might want to say yes, but a lot of times you want to say no. Don't renumber it and give it a brand new number, an unused number. All right, so again, 0.5 is this home space up here somewhere safe. All right, but it doesn't necessarily mean that's where my robot's going to start. So, you can see here my robot's way over here, but there's nothing in the way that I'm going to run into. And so when I run this program, then it's going to move over to the home position. And then it's, of course, it's actually going to 0.1 at 5 millimeters per second, which is really slow, right? So it's taking a long time to get there, even though I'm at 100% speed. Okay, I'm impatient, so I'm actually going to press hold and stop that. Turn my teach pennant on. I'm going to come over and bump that number up to, say, 50 millimeters per second, which is still kind of slow, but it's 10 times faster than what it was doing. Okay, so then I'm just going to press play again. Now notice it's going to return to the home position because it's going to start, let's see. It was paused. Okay, so when you pause it in the software, you actually got to stop it to restart it again. So I'm going to restart it. So return to the home position, and then it's going down to 0.1, and then it's moving in a straight line along there, and then it's returning back to that home position away from your part. So in general, you should always create a home position that's up in a safe area. And then when you start your program, you don't have to have the robot exactly at home, but have it up in that safe area. It'll move over to home, and then actually start executing the program. All right, so as we run this, again, notice that as the program runs, it moves along the box and it stops at each corner. If I now come over here to the termination and we look at my choices for termination, my terminations choices are either fine, which means go to that point and stop and then follow the next instruction, or continuous. Continuous says, hey, we're just going to kind of go near that point, and we may slow down, but we're not going to actually stop at that point. So continuous, if I select continuous, I actually have quite a few choices. Again, you got to turn the teach pennant on. All right, so I actually got several choices here. I'm going to start with choice 0. Okay, it's basically 0 to 100%. So I'm going to do that for points 2, 3, and 4. All right, and so I'm going to run this in auto mode because it gives these traces, which makes it kind of nice. All right, so now notice here it's going, from home to 0.1, 0.2, 0.3, and it looks like it's actually getting to 0.2, 3, and 4. So you see that it's actually getting to 0.2, 3, and 4. However, it's not hesitating quite so much. It's slowing down, and maybe just with a 0, it might be hesitating a little bit. So I'm going to come along here and I'm going to change these. You can just arrow over to it and punch in a different number. I'm going to punch in the number 9. I'm choosing 9 because I don't want to type 2 digits and type in 10. So it's basically 9% change. and I'm going to run this. And now what you're going to see is we run this. Okay, you see that it kind of missed it. See the red line there? The red line's the path it took. It kind of skipped the corner. It got close to the corner, but it skipped it. Okay, so you see that? It's looking at that distance right there. You know, as we move the mouse, you can see it's got like about 1 to 2 mouse pointers inside of here that it missed it. Now some of that's the software. It's kind of hard to see that exactly, but you see also here at 0.4, it kind of missed hitting 0.4 because it rounded it off, which means that it slowed down, it got close, but it rounded it off. Okay, so again, I'm going to kind of zoom in here. I'm going to keep this zoom, and I'm going to change these values from 9%, which is what it is now, over to 100%. Okay, so actually, I think I'll leave I'll leave 4 at 9%. So again, look down here at the corner. Here's 0.3, and you see how, you know, it's about 2 mouse lengths away, that red line there, which is the path it followed. And 0.4 here, you know, is about maybe 1 mouse length. But again, some of that's just the software drawing it. Okay, but we enter these in. So I'm going to, now 0.3, I made 100%. And what that means is we're just going to drive by, but we ain't stopping. And so you'll watch this as I run this one more time. You watch it. Of course, it's going to 0.1 and 0.2 kind of off screen here on the main screen. But we can see it up here in the other one. But you see how far away now it is? Okay, it never even got close to 0.3. It did get kind of close to 0.4, but it didn't actually go to 0.4. Okay, so that is the continuous. So what that means is if you do continuous 100, it sort of curves over that way. It didn't head in a straight line over to 0.4. All right, so it's sort of headed toward 0.3, but when it started getting close, it said, you know what? I'm close enough. My next destination is 4. I'm just going to wave to 0.3 as I cruise on by without even slowing down. Okay, so you see that it never got anywhere near 0.3. It did kind of get close to 0.4, but 0.4 was continuous also, so it didn't actually hit 0.4. And so that is the termination. Termination at fine means we're actually going to go there and at least hesitate or, you know, technically stop, even if it's just for a microsecond, and before we move on. Continuous of 0 says, well, we're going to kind of go there, but our hesitation is pretty much non-existent, but we're going to slow down. It's kind of like a rolling stop at a stop sign, which I know no one here would ever do, but that's kind of what the robot does if you do a continuous 0. But if you do a continuous 50, you know, it's going to slow down to about half speed and then cruise on by. And if you do continuous 100, it's just going to kind of head that way for a while, and then it's like, oh, I see my real next point, and over there I'm just cruising on, and it just kind of turns over toward the next point and doesn't actually necessarily get anywhere near this 0.3. Okay, so you need to be aware of that. And the other thing is, as you speed up or slow down the robot, the path that it actually takes may vary some. So always keep that in mind if you're not doing a linear or circular motion, the path may vary on you, especially with speed. Even though you've tested it at one speed, when you go up to full speed, it may not be the same. And the same with the continuous termination. If you change the speed of the robot, that path may vary.